Yeah, and Nara, so the panel is all in your hands. Yeah.
Okay, so we're starting.
Yeah. I believe most of the speakers, participants are still here, and seems I cannot see Stefano and not Alex and not Ranveer, not so far, but the rest are here. Yeah.
Okay, good evening, and let me start by welcoming all of you, and first of all, thank you all of you for your time, commitment, participation, and ideas that you brought to this workshop. It has been very challenging 4 months, and first of all, let me express a hope that all of you have been healthy with your families and friends, and the virus hasn't touched your families closely. I hope this challenging period will be over soon, and we can all get back to live events and each other, hold each other's hand and celebrate the events. And one of the big things that's missing from these events, I realized, is the celebration part. So we're not able to applause each other. So let's give big applause to all the speakers and celebrate this event. So the applause is missing from these events. That makes it kind of a little bit very formal and very, you know, like work. And right, so I have also my glass of wine to say cheers to everyone. So it's maybe not visible on the Zoom screen. So I opened a nice bottle of Italian wine. Italy had a hard time. So let's hope all this is over soon. This is an agricultural workshop. So without the sustainable agriculture, we won't have the nice wine as well. So here are a few questions I have put together. Thank you all again for your participation. We had, I think, very, very interesting talks. And the first question that I want to ask, what did bring all of us here together, right? So this is a question, this is a workshop that where we have been discussing how methods from artificial intelligence, computer vision, are helping to solve different challenges in agriculture. And why are we all here together? Are we here just to solve problems in agriculture, or we are also here to see how agriculture challenges computer vision on the other hand? How agriculture can help us to formulate new problems in computer vision that might have the potential to help other fields, for example, medicine, cancer research, or even the pandemics that's now around, right? So problems go two ways, as we know from exploring scientific disciplines. So I would like to hear all of you, and whoever wants to express an opinion, an idea, I guess there is a way of raising hand, or just maybe just speak up, put on your video and start speaking up. I will mute myself and hear all of you one by one. I just have 4 questions. I have emailed you those, and I'll go one by one. Just start talking.
Yeah, let me add one sentence here. So for anyone who is not too familiar with the Zoom, you can go to the gallery mode. And then if you click anyone's icon, there is 3 dots, and you can hide all the non-video participants. In that case, then you can only see the panels in your computer screen.
Seem to be a quiet panel. Can you hear me okay?
Yeah, I can go first. This is Sharath, Pankanti.
Correct.
Because there is a request to be brief, I'll say this, that if you look at the larger internet world, you know, in Google, I can search 45 billion web pages in 0.5 seconds. But in the physical reality, which agriculture represents a part of, I believe, you know, at least not even 0.1% of the physical reality is represented, which is the greatest opportunity, in my opinion, for not only just the agriculture part of it, but the entire food chain, sustainability, economy, ecology, everything is encompassed. So this is really a dream scenario for any scientist to make an impact. for not only their own humanity survival, but also the universe survival. So in that sense, this is biggest challenge, like Naira says, both for science as well as biggest challenge for the computer vision, because which is one of the key essential part of this. So I'll stop there, but I really feel like, you know, agriculture is the next bastion for computer vision scientists to make breakthrough.
Yeah, I can definitely continue. I want to double down on this point. We truly believe that perception and computer vision is a foundation for next generation breakthrough. The data that we use to correct in agriculture actually didn't really involve a lot of computer vision data, didn't really involve a lot of imagery, which I think for us to go forward, we need greater visibility into the details, into where on-ground is, into where those large-scale perception is. And that's what we believe, and we hope the industry can align together with the direction. Oh, I will stop here.
Okay.
I can.
Something to say. Okay, go ahead.
I guess, are we doing opportunities or all of the questions?
You can do questions.
Okay. Yeah, I mean, I think so. In terms of opportunity, I think that one of the nice things is that, you know, like someone mentioned, I think you can really study not just perception for perception's sake, but I think, you know, it really integrates with things like, you know, decision making, and actually being able to, you know, create decisions based on data that then affect the world, and then you can kind of sense the world again after those decisions, and then you know, see your impact. And I think, you know, maybe that's a harder problem to study because the data can't be just like, you know, the sensor data. You kind of need to involve all the, you know, various stakeholders and decision makers. But I think it's kind of a nice, you know, example, like application that actually, you know, integrates, you know, lots of different aspects. I think the other cool thing about it is integrating biology and, you know, physics and things like that. I think there's a lot of interesting scientific problems of how do you, you know, develop algorithms for data science or AI that not just kind of, you know, the best methods just to process an image, but actually incorporates our domain knowledge of, you know, how agriculture, how plants, you know, actually grow and how disease spreads and all these kinds of things. And how to incorporate that into the models themselves, I think, is an interesting kind of scientific problem. So and that is related, like if we make progress there, I think, like you said, you know, it could relate to other things like, you know, biology and disease and other understanding.
Okay, who wants next? Mulder, do you want to speak?
I can go briefly.
Okay,
I have
go.
one point to make. So I think this is more of a, I think, an opportunity. I see it as an opportunity. So I think with agriculture and in general remote sensing, there is this interesting aspect of, we really want to be able to do computer vision at fine scale, where we can, you know, be able to detect disease maybe by looking at leaves of a plant. But at the same time, we're interested in doing things at very large scales, so large farms. We saw that a little bit today. There were talks about doing things from satellite imagery, the whole state of, you know, several hundreds of miles of farms, analyze them and make analytics. But at the same level, there is interest in, you know, zooming in and looking at, you know, doing pattern recognition at a much finer level. And I think this is where I feel there will be interesting challenges for computer vision, machine learning. There's also the aspect of time. Like, things change on the field, but they don't change very quickly. There is a certain time scale. How can we do the analytics? How can we do the forward prediction? How can we like detect disease before the onset of the disease? And all those things, I feel, are really, there's some interesting technical problems there to solve.
Okay, who is next?
I'd like to say something. This is
Okay.
Delp from Purdue.
Okay.
So, you know, I've heard a lot of people here mention that, you know, this is an interesting computer vision problem. But, you know, from my point of view, it's a much more important problem in general. I mean, we're talking about how we're going to feed the world. And particularly when we're having global warming, you know, is going to be affecting, definitely going to have a big effect on agriculture. And I think these types of tools and this types of analysis and data gathering is going to be very important. The other thing I think it's important is that, you know, some people treat this as, okay, it's a sort of unique computer vision problem. But, you know, I've been doing this for, I don't know, 4 or 5 years now, you know, and it's really important to really talk to plant breeders and people in agronomy and things like this. Otherwise, you end up solving a toy problem. You know, you just have a problem that has a lot more data, maybe it has higher resolution, but then you get results that are sort of like, who cares, okay? So I would tell anybody who's really interested in this, thinks maybe this would be a good place to publish some papers, they really need to work with, you know, people that are sort of the end users, farmers, all the rest of that kind of stuff. But, you know, from my point of view, yeah, it's an interesting problem, it's a hard problem, but it's a very impactful problem. And I think we're gonna see more and more of this. We had a paper talking about, you know, trying to use some of these tools that impact agriculture in Africa, which I think is going to be very much an area that's going to have lots of trouble with agriculture and global warming. So these are the types of things that sort of drive me in this area.
Okay, let's hear Munzer say what's in Africa.
Great, thank you, Naira. And I want to underscore the previous comment. I think it's really important to recognize that this is in itself a critical area and a difficult area. And it's not really just an application of machine learning. In fact, it is not just an application of machine learning. I think that there are many aspects to this problem that makes it challenging and important. Well, first, it's critical because we want to feed the world. Second is because, at least in Africa and sub-Saharan Africa, it's a real issue of development. You know, farmers are very poor, and it's amazing that they are that poor given the resources that they have. But of course, it's a political problem as well. It's not just a sort of production problem. And so I think that one has to tackle this problem from all its dimensions. You know, there is the aspect of, can you actually produce good products, and then the aspect of who owns what and who has incentives to actually do better. And you have to sort of look at this problem in a sort of a more broader sense. There's the farms, which are extremely heterogeneous, different weather phenomenon, different production, time varying, as everybody said. So it's not a stagnant problem. It's an evolving problem, and the data is extremely sparse in that. So that's one aspect. That's the farms themselves. Then there are the farmers and who they work for and what they care about. And some of them own the land and some of them do not own the land, and bad practices and so forth. So that's another thing. And then there are the banks and the creditors who can enable the evolution of this. If you don't invest, you're not going to get much. But the investment is going to be really tricky because a lot of bankers don't trust. Well, first of all, a lot of the farmers, as I said, are poor, and so their history is not very productive. So you don't have the incentive to give them money. And the second thing is that there's almost evidence that 80% of the people that received funding from sub-Saharan Africa actually walked away with that funding. You know, so it's not like they've developed what they promised to develop. It's a very complicated situation there. And finally, there are the technology companies. The companies that are selling the fertilizers, selling the drones, selling the irrigation systems. They're not making any money yet because, well, there's no money flowing around. So you've got an economy that is locked up, so to speak. And what we're trying to say is that there's an opportunity to unlock this economy where it's a win-win situation for everybody. And that's, I think, how I view this problem as an amazingly challenging and broad problem. It's not just an application of one data set. So it's an exciting area.
You recall what Kennedy said in 1961 when he flew to moon? We'll go to the moon not because it's easy to do, but because it's a challenging problem to solve. And it's the right time to do it, and we are ready to do it, and we will do it, right? So now it's the time to solve this problem, right? With the moon mission, that's what Kennedy said. It stayed forever in my mind. Not that I was born then, but
it's a moonshot. And I think you're right. I think also, I just wanted to add one comment. There is a tremendous interest in sub-Saharan Africa. You know, I mean, the number of startup companies that are down there, the number of banks that have try to invest in that area. So the timing is right. There's just a lot of people down there trying to do the right thing or maybe make money and so forth. But for researchers, it's a great opportunity to be involved in that area. You know, so that's beyond precision agriculture.
Challenge. Right, exactly right. So Melba, what did you want to say? Please go ahead.
Yes, thank you so much. So I'd like to reinforce both what Ed said and you know, the last comment as well, having worked in Africa. So, you know, one of the things that we lack in our domain is really interdisciplinary education. We tell our, you know, we bring our students into these problems from a point of view of computer vision, signal processing, but they did not grow up and come into our field with the intention of actually doing this. They think they're all going to work for Microsoft or Google or do autonomous cars or whatever. And so, you know, it's a bridge that we have to learn to build. And we can't just expect it to, you know, happen, you know, immediately. And the immediate goal is I'm going to take what I know, I'm going to apply it, I'm going to publish it. So we have to, in order to have a real impact, we have to, as Ed said, really engage one-on-one, and thank God that a lot of these larger projects are being funded as interdisciplinary opportunities. But we also have to understand that, you know, what we bring in terms of our domain and the technology in terms of the sensing domain is going to have to be applicable in a lot of different situations, and one size doesn't fit all. You know, in Africa, then you're going to have a totally different set of opportunities and technologies that would be applicable than you would for, you know, a large scale farmer that might be, you know, in North America. And so I think we have to embrace this. And, you know, as you said, it's a huge challenge and a huge opportunity. But I think we have to embrace the whole thing if we're going to really have an impact.
Sure. Ranbir, you have something to say? You unmuted yourself.
Yeah, no, I'm agreeing with everyone. I'm really, so Naira, first, congratulations on organizing this workshop. I think it's great to see this kind of awareness being raised in the computer vision community. And I think other communities need to do this as well, right? My background is more in the systems and networking community. I usually go to SOSP, OSDI, SIGCOM, that community. We haven't, our paper on FarmBeats was originally accepted there. But it's great to see this kind of work happening in CVPR. Congratulations, and thank you for organizing this. And from our perspective at Microsoft, so I started this FarmBeats project back in 2015, right? And I've been working with Sudipta, Ashish, many other people. And through FarmBeats, our goal is to enable data-driven agriculture, right? Our goal is that how can we enable farmers to act on data in addition to the knowledge that they have, right? Right now, a lot of actions that they take is based on guesswork. And towards that, of course, we have taken a very interdisciplinary approach. We have networking, we have new technologies for networking, new technologies for edge computing, and some of the work overlaps with computer vision as well. It has a very important role to play, especially if we look at what we've been using from drones, from satellites, and balloons as well, which Sudipta talked about. And as we are starting to work in some of the things in sub-Saharan Africa, including looking at smartphones and things you can do on the phone itself, especially with images that farmers could take from the phone. And the one question, the way you led to this question, Naira, was on, does this have applicability to other domains? So what we realized is that while we started in agriculture with FarmBeats, ways to acquire data from remote sites and then combining all of these data streams to start adding insights, a lot of the things we learned here are applicable to many other industry verticals as well. Like, for example, energy, mining, even retail and things like that. But of course, it's the personal passion, the amount of impact that it can create that we've started with agriculture. And as we realize, agriculture is just the hardest domain to work in. Anything we develop here, it's easily translatable to the other industry verticals. It's much harder to do it the other way. I'll give you an example. Like one of the work we're doing is with energy companies, where with energy companies, we look at getting data from oil rigs. Of course, they have money. You have satellite connectivity from these oil rigs. You pipe all the data to the cloud. You can't expect every farm to have satellite connectivity. So that just, you have this problem of, okay, you need to be doing compute at the edge. You need to be getting a lot of data at the edge, doing some computer vision, machine learning at the edge, and then integrating that with the cloud. But if you solve the problem for agriculture, you can then translate a lot of the learnings that you have in this space to the other industry verticals. So for students who are in the audience for this panel, what I would say is, well, pick up agriculture. One, it is you're solving a hard problem, as many other people said as well in the panel. But in addition to that, while you publish papers, the work that you do, you can actually take a lot of the learnings and translate it to many other industry verticals. And I'm at Microsoft, so Dipta's at Microsoft. Kaushik, one of our interns this year, who's also in one of the attendees here, he's in the call. So we are hiring people with this kind of expertise, especially if you solve some of the hard problems here, you'd make an impact, both for agriculture and for other verticals as well.
Who else wants to talk before we move to the next question? Okay,
I'll have a quick say here. So at Intelinar, we're actually applying what the research here is happening directly on the field. We are actually spending time daily speaking to farmers about how what we're doing is impacting what they're having. The feedback loop is directly driving what the next things are that we're studying and where we're going. I think it's really important to keep that loop so that you're actually solving problems that they want. One of the challenges that we run into, of course, is as agriculture is one of the more difficult areas, is because farmers are probably the last to adopt technology. They're the first ones to come back and tell you, I don't trust your computers. I don't trust the results that are coming. And that trust takes a long time to come to fruition. We've been now 3 years in the business, and we're starting to get really a lot more people involved directly in understanding what the technology is and how machine learning, computer vision can really help them understand what's happening on their farm and help them make decisions now. I have one more point to make, and then I'll pass it back to you. One of the things that we've done is, because we fly across the entire season, we get that temporal view across the whole season. We're also helping farmers understand what actions they're taking and the impact that they're having on the field. And they're able to make decisions earlier in the season that can impact the outcome during that season. Before that, we had this capability of making choices and management choices based upon a broad view across your farm. A typical farmer had 40 cycles to learn how to run his business in his entire lifetime. Now we're giving them 2 or 3 more opportunities a year to learn how to improve their farm, so that that cycle goes faster and they learn faster and they're able to do better year over year in a much more effective way. I guess this is all important to, like, if you really want to get to that future, we have to accelerate how fast we're learning, and both on the machine learning side, but also at the actual agronomist level on the farm.
More responses, more people, more opinions.
Hi.
Okay, go ahead.
Hey, this is Liangliang. I want to be brief. So I think the opportunities, especially in the research aspect, is this field is very young. And I want to thank Naira and also Hongli. Thank you for the great tutorial and also this organization. I learned a lot from this, and I believe many researchers have the same thing as me. But the challenge is, I believe, is different farmers will have different requirements. So the solution will be very fragmented. And I'm now still curious how much accuracy do they need so that they would like to pay. And then what's the boundary for them to make a real change in their life instead of publishing papers. And I believe that there will be no unique answer. Probably there are many answers in different scenarios. That will probably the biggest challenge for me from my perspective. Yeah, that's my answer.
Okay, since we talked too long, let me just take a shortcut. So for the next year, as we are moving forward, so what do you think? Where is the future going? So we plan to continue these workshops, and the next question naturally would be, what type of communities to engage so that to grow in a meaningful way, to have impact for agriculture, and yet have good feedback for other disciplines, so that to strengthen each other in a meaningful way while having impact for farmers, for sustainable agriculture, to feed the 10 billion that's coming on our planet, yet have this opportunity to grow the other disciplines, high dimensional statistics, remote sensing, machine learning, computer vision, artificial intelligence, all this, so that we can have impact for medicine, for pandemics and other disciplines that are in critical need of innovation to be able to provide rapid response when needed. So who wants to talk first? So how should the future be developed? What other areas we need to invest on in terms of data collection, in terms of resolution of data, data structures, in terms of experiments that need to happen, in terms of economic infrastructure that we see in case of Africa that one needs to build to engage all these insurance companies, I don't know, governments that Munzer emphasized. So what's the kind of future development? How should we think about different things? Maybe different countries need different approaches because the methods and the approaches do not scale as one would like to see happening, right? When we have scalable approaches, then things are easy. But as we saw with pandemics, nothing scales even when you go from one country to another, from one state to another, things just don't scale. So what's the best approach? Who wants to start? Munzer, start.
Yeah, I can jump in. Thanks, Naira. So I think that, yes, I think the last comment you made is really on spot on. I think there is the United States and Western Europe problem with precision agriculture, which is a lot different than, say, sub-Saharan Africa or even third world countries. And I think that we need a more interdisciplinary, as the comment was made earlier, a more interdisciplinary team tackling some of these questions. Focusing on sub-Saharan, but I think India has similar challenges as well. There is the question of the political climate and how that impacts the whole business of agriculture. Countries are intervening, buying the rights to produce in these lands, and so there's an actual economic implications of this. So you can actually lease the land from the farmer, pay them a salary for not even working, and then take the farm and utilize it and sell the products. And I think this is actually causing even social problems that one has to think about. So there's just a multidimensional issue that is happening in sub-Saharan Africa beyond what I talked about, insurances and banks and fraud detection and so forth. I think economics, political science, social sciences have to kind of be coming together with maybe computer scientists and engineers who are trying to figure out the best ways and thinking about equity and social implications of the intervention for a lot of these places. It's exciting, it's more complicated, but it's also needed so that we don't do the wrong things and then end up having to backpedal. So I definitely want to support a more interdisciplinary approach to this problem. I mean, the data, there's no question, the data is the thing that's enabling all of this. If we didn't have data, we won't do anything, right? So, but the data is the different types of data that you have. You have data on the farms, you have data on the farmers, you have data on the political system, you have data on social behavior, how farmers see each other, how creditors see the farmers. You have a lot of different types of data, and to bring that all together into a system that then provides support is going to be challenging, but interdisciplinary. And I think that that's kind of, people have to start working across the board with other people. So, I think you said it at the end, right? I think this is a different problem for different parts of the world, and we should be cognizant of that.
Right, so there's no scalability from country to country, there's no scalability maybe even from one crop to another. So there's no master algorithm in reality, right? So But care and the devil is in the detail, and one should be really very careful what task we are solving, what is the representation, right? So all these problems, the way they are formulated in machine learning community, one has to be very careful to understand in detail what is the problem, what is the task, what is the representation, and what question we're trying to answer. So who else wants to talk? So who is next?
So this is Sharath here. While I completely agree with what Munzar was saying, it's a little bit of a divisive approach. Just as a kind of a start the discussion, I want to be a little bit contentious. Instead of saying, it's so difficult, country, political, and make it more and more challenging, so it will create a barrier for anybody who wants to do something about it. We can take another approach, which is probably a better approach, ground up. We can possibly form ourselves, right? Just like you started this first agricultural workshop, we could start a first consortium of agricultural sensor technology, call it by whatever name you want to, but we can form a united front where people can come for advice. Because if you look at many of the business reports for technologies, one of the biggest barriers is the hype cycle. For whatever reason, when the technology starts, there is no money in it. People tend to misrepresent what can be achieved, and a consortium is a good way to do a ground up work so that people who want to use it, early adopters, they can get a credible advice on what can be achieved, what is realistic, how problem can be tackled, and that can pave way for people to get encouraged to apply this technology and be satisfied that they are not really trying something snake oil. So that may be one way to just begin. And once people see the credibility that as scientists we are giving them sound advice, realistic advice, people may be encouraged, and that may start a virtuous cycle. And that may be another way to just bootstrap the expertise people have.
Great idea. So who would start that consortium? Should it be governmental? Should it be private? Should it be non-profit?
Naira, again, sorry, I don't want to be divisive here, because that is another barrier, right? Once we say somebody else has to start it, it has to be just like, how did you start this workshop? You didn't ask anybody, oh, should it be started by some agricultural expert, or should it be started by some industry? You just picked up and started. So I believe, we have enough brain power here that we can just put a .org and just start a website, and people can ask questions, you can provide advice, and so on and so forth. So it will be probably very low key, but that's one way to put a positive spin to the effort here.
I agree. So, okay, Ranveer, go ahead.
No, I was just pointing to Sharath that we are doing something like that organically with Purdue, UIUC, and Cornell, where we have this started with FarmBeats, where we are doing trials with each of these universities, and we have and NC State as well, all 4 like top agricultural schools. And the people who are part of this team are all like from agriculture, from computer science, from electrical engineering, and anyone who's involved with digital agriculture. We are all trying, but of course it needs to be expanded. It started organically with every university starting their Center for Digital Agriculture, and we participating as part of it. But now it's starting organically, and we are trying to bring everyone together. Of course, then there is this other initiative of the NSF USDA AI school that's happening, where I know some people have applied, and it's in the final stages, which might be an interesting one as well, interesting lead in, where that AI school is for one of the AI schools is for agriculture. If that gets funded, whoever gets it, that could be one way to get such a consortium started as well. I like the idea. I think there's some initiatives happening, and maybe it's right to start something like that, provide more guidance. Of course, there are industrial groups too, like Ag Gateway is there, and there are others, which is essentially a consortium of industries coming together, coming up with standards on sensing and APIs and so on. But that's I guess what you're talking about more is from a research academic perspective, where which this could be like the universities and the AI school. These could be ways in which everyone could come together.
Right. I mean, so there is a small distinction between the way industries come together with a particular motivation, but people would believe a lot more if scientists come together and provide some advice. They usually don't have any conflict of interest in giving a sound advice what to do, what brands to pick up, which technology to pick up. People may generally believe more. For example, 20 years ago, biometrics, where I started my career, it was equivalent to, essentially snake oil. But then, government with a little bit of help and academics, Joe Campbell, Jim Wayman from San Jose State University, they started the consortium. They started telling the various methodologies, best practices, and people started picking it up. And that influenced actually academic community to present their results with certain standards. If you don't have these many samples, you cannot really publish it in an archival journal, etc. So it kind of picked up a momentum of its own and a very, very favorable impact on both industry and academia. So I believe we could do something similar, not necessarily, whoever is interested, not necessarily restricted to this panel or this audience, but whoever is interested and has a spare cycles to provide, they can join.
Yeah, Sharath. And that's why I was saying that these three universities, these three land-grant universities, Cornell, UIUC, and Purdue, are doing the Center for Digital Agriculture. All three are doing it. They're calling it different names, but these are some of the top schools. And they are great schools in both tech side of things as well as in agriculture. And given that they are coming together, that might be an opportunity to bring them all along with the many other great people on this panel, right, and bringing everyone together.
Yeah.
The other community worth engaging with is out there is like the different, AI for social good organizations out there. Usually when you say AI for social good, your kind of three big leaders are, medical imaging, climate science, and then something around fairness, or, lack of discrimination or something like that. And occasionally agriculture will get listed as a subset of climate science. Climate change, addressing issues around climate change. But I think if you're thinking on the broader level, I think we're easily on par. Should be a fourth equal partner. And so we've done a lot of stuff trying to engage with that community. But I think the more we can kind of establish that link, I think it gives that certain amount of goodwill to it, that it establishing trust that this is not. It's not just a money play. It's not just about pushing technology down somebody's throat, that this is really a necessary step, a necessary evolution of our current practices in the agriculture field to address current challenges that exist, to prepare for the future, to do better. I think those are a lot of, most conferences have breakouts, or have workshops around that. There's, some that are more industry focused, some that are more academic focused, but I think it's a really interesting community that is worth engaging just kind of at every step along the way.
Well, I think in terms of organization, it might be important just to organize what type of sensors are important to extract useful information for agricultural impact, right? So sensors, then models that need to be trained on the data, right? And then some data can be for free, like coming from satellite, but some data can be very expensive, right, to acquire, yet they may bring the most important insight. So I think all these organization of data, sensors, methods, models, what is coming through expensive hardware, what is just the software aspect of it, where you need the experts, what type of training these experts need. And then one understands, okay, we need advances in high dimensional statistics, we need advances in I don't know. So topology, functional analysis, going deeper into math. So so that we provide the right training for the new generation of students who can grow to become the researchers with the maximum impact, right? So I think it's important to keep all these things in the perspective as we educate the students and as we work with industrial players, so that these consortiums can have the right impact eventually for sustainable agriculture, for feeding the population on Earth, and for future, right?
So I actually want to jump in on this consortium. I thank you, Naira, for organizing. We do see a lot of data collected by different partners. Everyone actually, at the day, I think is collecting a lot of data. What kind of data? Imagery data, farmer data, practice data, all kinds of different data. But one of the big problems, I think, is that not everyone understands how to use data universally. So we don't understand what is standard. We don't really understand data quality. We don't understand which data is good for what. To my personal view, I think it would be good for us as an industry, as a whole force, to really come out a standard to understand what data is good for what. And on top of that one, there's a lot of legal uncertainty on all the data usage, especially the privacy, the GDPR kind of regulation is coming in. It will be very, very good for us as a whole to figure out what kind of data can be used in which content. I think as a community, we actually lack the clarity on that part. That actually will be largely blocking us from moving forward, and also could potentially pose a lot of risk for us to move forward. Yeah, I actually would like to see how the panel would think about how we can avoid those, I would say, red holes while still advancing in sharing, in collectively moving forward for doing the good for the world.
So as a Google, what type of question you have for academics, right? So here is Zolt from Georgia Tech, we have Munzer from MIT, you are coming from Google. Pose your question. So we have Purdue people. So, okay, so Zolt, you have a question from Google.
Yeah, so I guess industry is a little different from university. From research perspective, probably the data for the research is probably easier to touch. But for industry, I think we have Microsoft friends here online, right? So it's going to be the same. We have a lot of legal concerns about using data and also how we can cover with other partners and not violating all the data terms and how to make sure that as an industry, as a collective community, we can all move together. We always believe it's an ecosystem play. To become an ecosystem, we need to figure out what's the interactions, what are the functions. And how we can make sure everyone participating is taking the benefit, and there's nothing bad, no foul play in the field.
I mean, I think in academia, I mean, we do, I guess, have freedom to use data as we wish, except that that data has to be available. So I think, without having specific, I think the best thing you can do for a domain is to democratize, right, a lot of data, such that the researchers that are working on that data don't have to have contacts, within, for example, like for agriculture, I don't have to know, companies that collect this farmer data and so on. So I think, while I agree, there's some freedom, I think that the mass release of like kind of multimodal kind of many region data, right? Even, for example, in order to study some of the interesting problems, such as like regional differences, let's say across satellite imagery, which, we've worked on, not for agriculture, but other domains. And we know that, a lot of the academic algorithms don't work well. So like domain adaptation, when you apply them to satellite imagery, it doesn't work as well. And the rankings of algorithms are much different just because the toy data sets that we use, like in academia, they don't have all the interesting characteristics. So, I think, yeah, it would be really nice to have like a much richer source of kind of multimodal or multi-problem, from UAVs, from satellite imagery, from, ground images and things like that, and be able to actually have access to that. I think that would help a lot, because I think, again, the current algorithms don't really cover all the challenges. And I think, it's hard to generate such data. And if I just get it from one particular source, it doesn't really capture this complexity. So yeah, I think some of the other talks, that people were talking about, kind of democratizing or giving access to everyone, a very heterogeneous source of data sets. That would be great to move everything forward.
Yeah,
just to add to that.
Oh, sorry, go ahead.
Give me just 1 second. Just to add to that, one of the bigger challenges of data sets is ground truthing the information. Like you have freely available satellite data, but what does it really mean if you don't have a way to prove what it is you're actually looking at? You have to have some way of doing that. We have a very large data set. We even struggle internally with how do we ground truth. We're collecting over 3 million acres every week of high resolution imagery. We just don't have an army of people to go ground truth what's happening on all those acres. And so we have to be strategic about what we do. We only get a subset, and that data is just really hard to come by.
And also, I guess, in this kind of domain, I don't know that there is one ground truthing, right? Basically, like depending on the task or like what they're using it for, you might have a different label set, right? So almost you need to kind of, I don't know, somehow, again, kind of leverage a lot of unlabeled data, but also kind of allow the end user to also determine kind of what they're interested in from the data.
And I think some of the challenge of that is if you wait 6 months, you can't go back and ground truth. Like the crop's already grown and been harvested, and now you can't go out and ask the question, well, what was it doing on this day? It gets very hard.
Yeah, I want to chip in a few sentences to what Jim was talking about. So I think this actually provides a good opportunity for collaboration between academia and industry. So for example, you have concerns about this GDPR, this like privacy issues. In academia, well, it's a little bit more flexible. We still need to go through like IRB, but we could do like small scale experiments. And like for example, Google X or Microsoft can give us some small data set where you define what is the problem, which is really important for both for industry and also for your clients, which means like people around the world. And then we can solve this problem in a small scale. And then we can turn like our base models where base results back to Google, to Microsoft. And then I think that will just be a very good and simple cycle where we collaborate and we make the problem like solved a little bit more than before. And actually, this is how we work with Intelinear. So for example, David just said that they have 300 million acres and they have tons of terabytes of data. And we try to collaborate and work on this price challenge where we select a small set of the data that we define very clearly what kind of problem we're going to solve. Actually, we narrow it down to a semantic segmentation task this year. And we annotated only a few types of the really important patterns that's going to affect the yield of the farmers. And then we solve this problem and we get some baseline model. And luckily, we got an even better model through this price challenge, which will be able to help the farmers in the future. And eventually, this need to be iteratively like updated multiple times to get a really good solution back to the company to solve the actual problem in the real world. Yeah, thanks.
Thank you, Harpreet. So I just want to dive that one. I think actually, if you look at the computer vision, right? So real breakthrough is we have this ImageNet data set. I don't think agriculture has something called ImageNet yet. So for my personal interest, I think we as a company also are interested in investing in certain way, finding partners to really publish something called ImageNet, right, for agriculture. I think that will probably be game changing.
Let me tell you a small story. Actually, in the beginning, Naira and I first named our data set AgImageNet. But later we changed the name to Agriculture Vision for two reasons. First is we really want to bring together agricultural community and computer vision community, especially computer vision and pattern recognition community. Second is really I like the name where we're looking for the vision for the agriculture in the future. Yeah, so yeah, hopefully we can find some like more ground to collaborate in the future. Yeah, thanks.
Yeah. Agriculture problem really pose many new technical challenges beyond the common challenges in current computer vision community. First, as mentioned before, the training side is hard to be obtained, And currently, deep learning with supervised training has proven its effectiveness. But currently, I think, take the agriculture vision dataset example, I think the annotation is very difficult to be obtained. So how to, in the future, how to perform the semi-weekly or unsupervised training will be, I think will be very important. Second, the agriculture recognition in agriculture is totally different from other recognition tasks such as for face, we can have, we know there are 2 eyes, nose, and mouth. And for person, we know head and arms and legs. But for agriculture picture, there's no common pattern to be learned. So it's another challenge. And beyond this, I think data storage and such as the huge data storage and the real-time inference and the efficient model updation with historical information, I think are all challenges. So since there are many problems in agriculture, I think to moving forward the research, we may target on some very small and specific tasks. And this task should be very well-defined. I think a well-defined problem and application may often attract more researchers. I think another is build a reasonable data set. If the data set can really cover the well-defined problem and the achievements made in this data set can really benefit the real-world applications. Yes, thank you.
Yeah, I'll echo a lot. I kind of actually going back to the first question, I think what makes this field very interesting to me from the scientific side is in some ways it almost takes all of computer vision and kind of turns it on its head in sort of a way. And it's a little bit ironic in that, you know, one of the foundations of computer vision is, you know, natural scene statistics. And right, and here we are in a very natural environment, and yet a lot of our approaches don't quite work, right? And so I think it's just a really interesting way of like the size component, as we just mentioned again. You know, we talk about it having, having lightweight models and having energy efficient models and saying, well, we can make an environmental impact for these farmers. But if we're just burning through compute because we're going to process everything all the time, every way, at every scale, you're going to eat up your economic margins, and you're going to have a little bit of a economic or a environmental kind of downturn on that as well. So like a lot of things that work in theory, when you go to, you know, apply it at this, you know, is probably the most massive scale that we can think about, all of a sudden you have to start reevaluating, you know, what those approaches are. And then I think that, you know, as I mentioned this morning, I think the weekly supervised, the unsupervised, like how do we get labels? Like what is the right way to get good, consistent solid labels is just a really, that's a topic that particularly excites me.
Alex, you came late. Maybe you talk a few words, Alex.
Yeah, I was just actually jumping in there. Similar to what Jen was saying, I think we have, with agriculture, we have a set of new problems and questions that the computer vision community as a whole can actually look at. But what we need to do from the agriculture side is kind of precisely specifying, as others have said before as well, what are the tasks that we ought to address? What are the important tasks? Right? I'm doing a lot of research in computer vision and machine learning, but and I'm not an agriculture person. So from my perspective, you know, I need some guidance along the way of what are the important tasks, what are the real challenges, and I feel like that is something that the community is also lacking here. Not only what are the algorithmic challenges, but also what are the important questions. And there, as an agriculture community, I think we could do a better job in, you know, very carefully formulating what are the important aspects.
Sure. Jennifer had some questions for you. She will email you. She emailed me. I said, okay, email Alex directly. So anything else somebody wants to bring up? So we are in the last few minutes. I guess we discussed plans for future. So we will be working on putting the second workshop proposal with Honghui, and Jennifer will invite people to join in terms of data sets, in terms of topics as we plan it for the next year. So the deadline will be sometime in November. Thanks for expressing great interest. We'll think about the consortium, like Ranveer suggested, together with Sharath. So we'll engage everybody. We'll grow the community, keep everybody interested. Last minute thoughts, if somebody wants to express, let me know.
I think someone has a hand raised. I'm not sure whether that is a question or just accidentally.
Oh, raise hands. How do I find it out?
I think Sharath raised hand a long time ago.
Oh, okay.
Yeah, I don't think he put his hand down is what the problem was.
Yeah, no, that's a mistake. I don't have anything more to say.
Yeah, thanks Sharath for the great idea about the consortium. Yeah.
Okay, and I want to thank also finally the company for sponsoring the prize challenge. So Intelinair sponsored the prizes. So we'll grow the prizes also next year. So the data set will grow. This year we had only data set from the early season. Next year, if we get more companies sponsoring the prizes, we can grow to have bigger data set, more diversity, early, late season, different crops, and so on. So those announcements will come out, and hopefully we'll have a bigger consortium where different companies will contribute to the prizes. And we can eventually have maybe next prize for agriculture, starting from this very first CVPR workshop, virtual one, happening like this on a Zoom call, and we'll remember this like a historical event. So thank you all very much. So big applause to everyone. This is what we miss now from the live events. Cheers to everyone with a glass of wine. So, and stay healthy, stay away from the virus. And thank you all for coming. Thank you all for supporting this workshop, okay?
Yeah, thank you very much for organizing. Thank you so much.
Yeah, thank you very much.
Thank you, Mother. Thank you all. Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you.
Yeah,
Mm-hmm.
thank you guys.
Bye.
Bye-bye.
Bye.